In this video, we are going to prove the alternate interior angles theorem and then apply the theorem in problem solving. This is the alternate interior angles theorem. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent. This is the figure. This is the line M. This is line N. These two lines are parallel and they are cut by transversal T. This is the angle 1, this is angle 2, this is angle 3, and this is angle 4. Angle 2 and angle 3 are vertical angles. Angle 3 and angle 4 are alternate interior angles, and angle 2 and angle 4 are corresponding angles. For the given data, we have line M is parallel to line N, then transversal T. We are going to prove that angle 3 is congruent to angle 4. We are going to use a two-column proof. In the first column, we are going to write the statements, and in the second column, the corresponding reasons. For our first statement, we have line M is parallel to line N, transversal T. The reason given. For our second statement, angle 3 is congruent to angle 2. Angle 3 and angle 2 are vertical angles. According to the vertical angles theorem, vertical angles are congruent. So our reason is vertical angles are congruent. For our third statement, we have angle 2 is congruent to angle 4. Angle 2 and angle 4 are corresponding angles. According to the corresponding angles theorem, if two parallel lines are cut by a transversal, then the corresponding angles are congruent. So for our reason, let us just write corresponding angles are congruent. In statement number 2, we have angle 3 is congruent to angle 2. And then in statement number 3, we have angle 2 is congruent to angle 4. This is just like saying if A is equal to B and B is equal to C, then A is equal to C. So if angle 3 is congruent to angle 2 and angle 2 is congruent to angle 4, then we can say that angle 3 is congruent to angle 4. The reason is transitive property of congruence. Let us solve this problem. Line M and line N are parallel. If the measure of angle 1 is equal to 6x minus 5 and the measure of angle 2 is equal to 3x plus 16, find the measure of angle 1 and the measure of angle 2. This is the figure. Line M is parallel to line N. This is the transversal T. This is the angle 1 and this is angle 2. Angle 1 and angle 2 are alternate interior angles. According to the alternate interior angles theorem, alternate interior angles are congruent. If they are congruent, then their measures are equal. So we can say that the measure of angle 1 is equal to the measure of angle 2. it is given that the measure of angle 1 is equal to 6x minus 5. So we can substitute 6x minus 5 for measure of angle 1. And it is also given that the measure of angle 2 is equal to 3x plus 16. So we can substitute 3x plus 16 for measure of angle 2. We have now 6x minus 5 is equal to 3x plus 16. Let us solve for x. We transpose the 3x to the left side, change its sign from positive to negative, and then we transpose negative 5 to the right side. We changed its sign from negative to positive. So we have now 6x minus 3x is equal to 16 plus 5. This is now equal to 3x is equal to 21. We divide the left side by 3, and then we divide the right side also by 3. So x is equal to 7. It is given that the measure of angle 1 is equal to 6x minus 5. We already know the value of x. It is 7. So we substitute 7 for x. This is now equal to 6 times 7 minus 5. 6 times 7 is 42. So we have 42 minus 5. And 42 minus 5 is 37. So the measure of angle 1 is equal to 37. So angle 1 is equal to 37 degrees. It is also given that the measure of angle 2 is equal to 3x plus 16. We substitute 7 for x. This is now equal to 3 times 7 plus 16. 3 times 7 is equal to 21, and then 21 plus 16 is equal to 37. So the measure of angle 2 is equal to 37. So angle 2 is also equal to 37 degrees.